Sound test, 1, 2, 3. Sound test, 1, 2, 3. Testing 1. So I should be back on now, testing 1, 2, 3 again. It's switched off, people online, and you can hear me now. So we are live, guys. Hello, welcome everyone. This is our first ever stream from this space, so everything that can go wrong probably will, so don't have high expectations today. You know, things are going to get messy and funny, I hope so. So welcome. We have people online on a YouTube channel, and some people who want, they can probably see this later. And we have people in the room as well, you know, so thanks all for joining. It's going to be hopefully interesting, okay? So first of all, let me tell you some introduction. I'm not going to do this every stream, this is today only. So we have this place which we call Alihaba, and it's a digital innovation hub. So what we try to do is help people in the city of Maastricht, but also in the region of Limburg, but also in the whole EU to do something with their ideas. So we want to help digital innovation. It's a non-profit organization, so lots of companies here are joining forces together in order to deliver to the region what this region needs. What does it need? We don't know. Okay, it's a simple answer. So we are trying to find out, and we want you guys to tell us what it is. You know, so we have guys from Nesteg, you know, guys from Emosys and the Co-Town and Upsworth and different little companies who work in the region, trying to do something together for the region, okay? So we are going to have lots of events, hopefully, that they will be good events, so that people will come on various topics. And this is the first one of those events. So the first one of those events is some sort of development school, but not like any other that you have seen so far. So Alihaba, that's what it is, Digital Innovation Hub. You know, you'll find more on our website, which we are building at the moment, so don't go there because it's currently a mess. Who am I? Okay, so my name is Ondrej Fabris, and I am Executive Director of Upsworth BV and Limited, you know, UK version of the same company. Okay, so I am actually a mechanical engineer. I studied to build and repair ships, and I never put my foot on a ship in my life, okay? So because I was always interested as a kid for programming and computers and stuff like that, you know, computer games, doesn't matter, a little geek, you know, so, and that was ages ago. We had computers which were made of wood and I don't know what, you know. So, and I started developing my own games. And then after a while, I got to work for BlackBerry, okay? And this is when the BlackBerry were good. They were actually called Research in Motion. This was before Apple and so on. And my job was application development consultant. So my job was to tell all the companies, and I had more than 170 companies, how to develop applications for the mobile phones, the first application, okay? So Skype, Spotify, all the banks, all the avio companies who wanted to sell tickets, KLM, you know, you name it, they worked with me, okay? They asked me, how do we do this? And that was half of my job for the BlackBerry. The other half was to go across the Europe, travel around and do presentations. So I was presenting in Mobile World Congress in Barcelona and all the others, telling developers, hey guys, you should all be developers and come and join and do good stuff and crazy stuff. We can change the world and all that sort of stuff, okay? When I left BlackBerry, of course, the company went down the drains, and then because I started my own software development company in London, it was called Code10, so we did that for 5-6 years. We did around 100 projects, okay, for different customers, small businesses, but also large businesses. So we developed quite a lot of those, you know. So, and after that, I decided to become a digital nomad. So I bought a camper, and me and my Dutch girlfriend, we sat on a camper and just drove across the Europe for a year and a half or two or something like that. You know, so we were everywhere, and that was great. And she got a job in Maastricht, so now here in Maastricht for some reason. But in my old company called 10, we developed our product, which is called AppsForce, okay? And since I stopped working there, you know, I was like, yeah, I don't care. But then when I settled in Maastricht, I was like, what the hell am I going to do now in Maastricht, okay? So then I remembered my AppsForce thing, okay, let's make this as a new company, new project, and so on. So 2 years later, here we are all, you know, so it's been going well. We got, I think, around 8 or 10 European grants in various things. So that's a little introduction about myself, but you can see that I do have a lot of experience in how to develop stuff and all sorts of projects. I'm also CTO of a couple of companies like CodeTown and so on, but that doesn't matter. Okay? So enough of introductions. Now let me introduce the course that we are going to do. Okay? So we have a rough idea what we want to achieve, okay? The main goal is to teach you guys how to think differently, okay? You all know how to think, but I want to teach you how to think differently. Think as a programmer, okay? And that's why there's a single course like this online on YouTube and so on, okay? It's going to be completely different. You are not going to get used to this easily, okay? So if you want to have a course how to set up your development platform, you are much better off watching any other YouTube video. You know, it's much better than this one. Because the guy will specifically tell you, or the lady or whatever, you know, you need to download this, here's the links in the description, you know, they professionally edited and so on. We are not going to do that, okay? We're going to do something different. We are going to be very interactive with each other, okay? And you will also have homework, okay? So you will have some stuff to do as a homework to practice it. So I'm seeing that, you know, people actually are posting messages on the stream, you know, so if you have any questions, you know, and you are watching online, please just type them. I can see your messages. I'm not going to answer every single one of them right now, okay? And also, if you have questions, if you are here, please do ask them, you know, straight away. The guys on the stream probably won't hear you, but I will repeat the question in both ways. But I might answer it later as well, okay? So I might not answer specific questions that, you know, Sam wants to know for her own purpose. I'm just going to think about wider audience. So I'll say I'll come back to you directly if you ask me that question, how do you do that on your laptop, okay? But they are the questions which are covering everybody. I'm going to try to answer immediately, okay? So what I want to do is, as I said, teach you how to think differently, okay? So we are going to talk about concepts and stuff in a bit wider range, first of all, because it's very important to understand the concepts behind the things. But there's another thing, okay? Because I watched some famous psychologist explaining how education works. And the problem with education is that you try to force new knowledge onto the people, that you keep giving them new knowledge. But you don't take away, first of all, the wrong knowledge that they have, okay? So if I tell you the earth is flat and you know it's round, you are never going to believe me. I first have to convince you that you're thinking the earth is round is wrong, so you don't believe that anymore, and then I can give you the new information that you can accept with my arguments. So it's important that I learn from you guys what your ideas and concepts and thoughts on these topics are, and then I prove them wrong, and then I can tell you, forget what you know, now this is what you need to know. So it's going to be a struggle sometimes, okay? But we'll see how that is going to work. So what I also like to do is a thing called problem-based learning, okay? So you can read a book which is theory, okay? Fine, you know lots of theory, okay? You can give example task like, hey, you know, Mary has 3 apples if she gives 2 to Merdad, that never happens in the real life. Okay, so you know that, but it never happens in the real life. So what we are going to do is actually work on the projects which are real projects for the real customers in real time. Okay, so we are going to do this on a real problem. Okay, and you have to solve this problem, and through solving the problem, you learn new skills. Okay, so that's the methodology that I apply. Okay, so typically what I'm going to do is give you a little lesson, talk about the stuff, and then I'm going to actually communicate with you guys. I don't know how they're going to work on a live stream, but you will see. So I'm going to talk to you guys and ask you questions and thoughts and having a discussion and so on, so hopefully people can learn from it. All clear? Any questions? Guys on the stream, they're always like 30 seconds behind, so shall we move on? So, setting up development environment. Let's not talk about that right now. Let's talk about something completely different, okay? Let's talk about what the hell is a computer. Okay? You think you know. Okay? Do you know who invented the whole logic behind the computers? When was it? How old is that technology? What do you think? How old is this, the whole technology behind computers?
I have no idea.
Well, give a guess.
1950.
1950, so around 70 years, okay? So anyone else?
Yeah, 100 years ago?
100 years ago, okay? What do you guys think over there in the back?
I'd say older.
You think older, yeah?
I remember that I read something that the first computers were calculators, so it's way before or no?
Yeah, but it is way before, People were making mechanical analog computers for years, okay? You have a couple of thousand years old mechanical devices which were calculating where the positions of sun and stuff is, okay? But the first guy who actually mathematically did what we are doing in the computers was in some 18th century or something like that. He never heard of a bloody computer, he didn't know the word computer, but he put all the calculations and all the equations how modern computers work today. And the first computers didn't work on electricity, they were mechanical. Okay, so you had mechanical switch, which had 2 states. Is it switched on or switched off? Okay, so this guy was talking about binary system and ones and zeros, which you all heard of, but 1 represents switched on and 0 is switched off. So we have very easy thing called, okay, logic. Okay, is it true? Is it false? Is it on? Is it off? Is it up? Is it down? So it's 2 states. You can do it with a mechanical thing, anytime. Is my cup full, empty, etc., etc. Okay? So these were the first computers. Then they invented electricity. So you have a mechanical switch. You can turn it on and off. Click, clack. Okay? That can be used for the computers to represent states. I don't know, do you remember or have you seen it? We have these old television sets, and they were huge, they were this thick, and they were 1,000 kilos heavy, and you open them inside, and you have these tubes, and they are like little sci-fi village, Those tubes were switches, but run on electricity, okay? That was amazing, They were extremely slow, unreliable, etc., etc. But the first computers, when you hear the stories of the first computer, supercomputer, was like, it took, 5 floors of a building, it was 5 million tons, and it took half of Manhattan's electricity, Yeah, it did. And what it could do, it could actually add 3 numbers or something like that, So it was a great success, But it is the same principle that we have on today's computers. You have the most modern, this one, that one, that one. They work exactly the same. Switch, 1, 0. The only difference is somebody invented a thing called transistor. Okay, so instead of these big tubes, you could have a small transistor, they have a small one and smaller one, they can put them together, and then you call that thing a processor, lots of transistors together. Yeah, but that's what it is. Each transistor in your processor that you have in your computer is a little switch, on, off, click, clack, okay? So, they are trying to make quantum computing something new, which will not have these two stages on and off. We are trying to get something which has 3 stages, on and off and maybe. Okay, it doesn't matter. That would make huge revolution in speed, capabilities and stuff like that, just if we can have something that is small, fast, and can have 3 different stages. So the oldest computer, the mechanical one, the one based on tubes and transistors, doesn't matter, and so on, they had to do something, and that something is to do some calculation, do some operation, do something, okay? That's the whole point of a computer, it has to do something. And we have to tell it what to do. And that thing was called programming the computer, okay? So this is what we are doing. It's the same thing that we've been doing for, since the guy invented Boolean algebra and all that, So we've been trying to write a code, okay? But since the base technology hasn't changed, it's always has been the same. You have to write a code called machine code that these stupid switches can understand, that they can't understand thing, it's just a switch. So you can tell the switch be on and be off, that's it. But if I have 1,000 switches, then I can say, you be on, you be off, you be mixed, and so on. And I can say on, that represents letter A, off is N, on-off is D, and I'm spelling A and D, I'm spelling my name. So I'm actually giving some sort of meaning to those stupid switches, okay? But you have to do that on such low level, you have to do it step by step. You have to say first group of switches be like this, 20 commands. Okay, second group of switches be like that, another 20 commands. Just to spell somebody's name, it was horrible. It wasn't easy, okay? So you had to be very, very patient and a great expert in order to be able to do this sort of stuff. And people are still doing this because we still need to program the new processors that we are building on this level. At the end of the day, we build some nicer tools which help us to do that, okay? But coding is writing a little application, so whatever we call those few lines of code or lots of codes, is application, that will do something, okay? So I will use an example. I have a picture saved on my hard drive, which I want to display on my screen, okay? If you are using modern Windows and stuff like that, you don't have to worry about that. You use your mouse, you click, and it happens, okay? But it doesn't happen really because somebody had to code this on multiple levels. So the actual processor, the switches in processor, have to instruct hard drive to get some data from specific sector and then move that data into the memory where a specific location, so some other switches in memory have to be in that state, and then some switches have to open towards the monitor in order, so there's lots of going on, okay? But luckily we don't have to do that, we just do click, and now it's much easier, okay? But that's what happens. That's the machine code. Nobody writes in it unless you want to learn how to make new processors and stuff like that. Nobody needs to know that. So what they invented after that is some sort of group of those commands. And because it was so hard to make it into using machine code, they invented new languages, okay? So you would have a language where you would write something which is like almost English, and then you would run another program which will compile that into machine code and then feed that to computer. So you say what you want to do in one language, compile it, and then computer can execute it, okay? Of course, if you made a mistake, it can't compile, then you have to figure out what the mistake is. But that's pretty much what we are doing these days still. The only difference sometimes is that this compiling can happen on the go. It doesn't have to be pre-compiled. So we have some stuff that we need to compile, some which we don't need to compile. So it doesn't matter what programming languages you know. Do you say, I know JavaScript, or I'm familiar with framework called Angular, or I know PHP, or whatever? Actually, it doesn't matter. Okay? I'm not going to talk about that today. I'm talking about how the computers work. You have to understand the basic concepts, how the fuck they work. Of course, if I speak your language and tell you things in your language, you will understand me very quickly, and you will be able to execute stuff very quickly. But if I don't speak your language and I need translator, her, to tell her what I want, and she translates to you, but she translates wrongly, and then you go and do completely wrong things, of course it's better if I speak your language directly, okay? So it works faster. So the more complex the language is, there are more translations happening, and there's more room for error, okay? So what they build this kind of a DOS disk operating system and Unix and POSIX and stuff like that, which is all kind of same idea, okay? So you have some sort of terminal where you can type a little commands like ls, and then it would show you the list of files in that folder, or you would type cd and it would change that folder, you know. So these little ls and cd are little applications compiled, so we don't have to do it again and again, okay? So they built this first versions of this command terminal kind of language that you can, you know, easily understand. ls stands for list, okay? So you can remember that it's much easier than switches and all that, you know. So what we are trying to do, we made a huge progress with that, okay? So you didn't have to have 3 PhDs in order to add 3 numbers on a computer. You could do it yourself much easier, okay? And then what they did later is like, why don't we add some interface on top of that, okay? Like graphics interface. Why don't we make it into some sort of network of computers so the data can go from one to another, okay? So it's making it more and more complex, and it's adding more and more steps. But computers are getting more and more powerful, so we think it's all fine, okay? So in this terminal language, let's call it terminal language, it depends, is it DOS or Unix or POSIX or whatever not, you know. You could do the same thing what I said to you, you know, much easier to load the picture and put it on the display. It was much easier to do that, but it was still quite complex. And if you do that things again and again, what you would do is you would write a little script that you can save and call it, I don't know, PIC, and then you call pick, and it would do it for you, so you don't have to type it again and again. So you can make a script, and then because if that script is good, then it would be added to the next version, so next version of DOS or POSIX would have more commands added to it. So it keeps growing, okay? But those commands are typically written in, I don't know, C++ or C# or one of those. I don't care, okay? But we are not writing here and learning how to program the core operating system. Okay? So as I mentioned, the next step forward was invent some sort of graphics interface. So Apple and Xerox and Microsoft, they all did that, you know, in the different ways. And then Linux came up with, okay, so they, on top of this, they put some sort of visuals. Okay, so you don't even have to type those commands, you can click on buttons, okay, with some sort of pointer mouse. But what will happen in the background, you will have another code which would check where the mouse is, where the button is, it has to draw that, and it will check, did you click on the button? And then what that would do is actually call this pick command that I just mentioned before, okay, and execute that code. So as you can see now, I move from switches to this code to more complex code and more complex code. So I'm making it much harder, many more steps to do. I think Windows 11 and so on, they even forgot about DOS. They say, okay, because that's too cumbersome, okay, so let's do directly. So when you click on the button, we will rewrite the whole thing, so you don't have to call this pick command anymore, because it's 20 years old, so let's make it more optimized, you know, but it's the same principle. Still, we are talking about switches. So you have Windows or Mac OS or whatever, Linux, it doesn't matter. And then now we are building applications that run inside that. And the famous application is called browser. Okay, so there you open a browser, and what browser does is get some code and executes that. But you have to see this is another layer on top of the layer. Now, when I click on the button on the browser, it has to process that code, the application browser, it has to translate it, then it has to tell Windows what to do or Mac, then it has to translate it into machine language and so on, and it has to, you know, so it's just getting more and more complex. But that's a simple HTML button. But you say, hey, why don't we make the button look green, and if you click on it, it changes something or opens this thing, you know, so let's make it even more complex and more complex and more complex. So as I said, we are just adding the complexity and the complexity to the equation, okay? So what does that have to do with setting up your development environment? Well, it has to do everything, of course, because there's no right way to set up your development environment. There's not the best way. This is what it is supposed to be. Okay? Because it really depends what you are trying to achieve. Okay? What sort of programming you want to do, because it's going to be different if you are building some small devices, embedded devices, little sensors and stuff like that, where you need that machine code almost level, or you're building something which is going to run in a website. But then we also invented, hey, why don't we just have mobile phones as well? Okay, mobile phones, it is a computer. There's no difference. Same thing, switches. Same thing, exactly. Makes no difference. Is it your DVD player? That has to be programmed. Is it your modern fridge? That has to be programmed. Is it mobile phone? Is it Apple? Is it Android? Is it Windows 10, Windows 3.11? Makes no difference. If you are a programmer, it makes no difference because you're still working with switches. And you still have all these steps. And we forget about that all the time. I talk to so many programmers, especially young ones, and they are like, Angular, 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 you know, what is Angular? How does it connect to everything? I'm data scientist. Oh, great. What does that mean? What's the data? You know, how is it stored? How is it accessed? How does it connect to the meaning of life? No, I know. Guys, it's very important to never forget we have very complex technology, and it is going to become more and more complex every day. So development environment. There is no perfect development environment, okay? There isn't one. And even if I give you the best perfect environment today, tomorrow is going to be obsolete because we'll invent something new and you need to change it. You need to upgrade it, okay? So this is the problem that we have, number one. Number two is, of course, we have to learn those new things. So we have to keep learning and upgrading and keep learning and upgrading. This is a job that you can never stop learning. It's not like a history teacher. You learn history once, it's not going to change suddenly. You need to upgrade to history 2.0. It wasn't Napoleon, it was, three other guys, who started whatever. Okay? So, development environment really, 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 there is not a perfect one. So what we need to do? We need to apply two principles, okay? We have to make it easy for us to program, okay? So it has to be easy for us humans to interact with it. So the development environment that we need to build has to be logical and easy for us, okay? Because if it's hard, like machine code, that you had to punch holes in some cardboard and then put it in a machine, that's very hard. That makes no sense. So the better environment is the one that we understand the best. So it's optimized for humans, which means it's not optimized for the machines whatsoever. Okay? So if it's easy for us, it's hard for the machines. There are too many steps, too many things that can go wrong, all right? So when they say there is this great new thing, React Native or whatever not, it's absolutely great. Yeah, it's good for humans, but it's really bad for the machines, okay? And I'll come to that point later in one of the sessions. So there's one, okay? We have to make our development environment work for us, to be suitable for us. The second rule is we have to make this development environment as close as possible to the real thing, real application. Okay? If I'm building a website which is going to run on a server located in some big data center, which runs on Ubuntu version 18, has MySQL database version 8, and has PHP version 8. If that is going to be where my website is, it has 2 gig of RAM, okay, and it has 20 gig of hard drive space. That's where the site is going to be. How the hell am I going to make a development environment on the PC which has 32 gig of memory and terabytes of space and so on? It's not going to be exactly the same thing, is it? And also on my PC, I'm running Skype and I am having my Spotify music and so on, and that's not real. Okay, so because as you see, we have this complexity, and all this complexity makes sure that it's not going to work really well. So the idea, the second rule, is that your development environment has to be as close as possible to the end product, because then you will have the smallest headache of deploying it and making sure it works reliably. It's like you tell me, hey, Ondrej, I have this nice car Mercedes. There's something wrong with it. There is a bug. It doesn't work. I was like, no problem. Let me debug that on this bucket. I have this bucket, which is completely different to your car, but I will debug that and try to figure out by looking at the bucket what's wrong with your Mercedes. It's not going to work, is it? If I have exactly the same Mercedes and to try to look at that, I can figure out what's wrong with this Mercedes but without ever touching it. If I want to optimize performance of your Mercedes, I can do it on exactly the same Mercedes, make sure that it works fine on my development environment, and then when I get that solution on this Mercedes, I apply it to your Mercedes and that person's Mercedes and so on, and everybody's happy. So 2 rules for the development environment. Do you remember the 2 rules?
What was the first one? Nothing complex or complex?
It has to be easy for humans.
Easy for humans.
Okay, it has to be easy for humans. You have to make it work for yourself. Okay? But that's not always possible because the servers that are going to run our code are not optimized for humans. They're optimized to process 1 million requests or 5 million requests. They're all not optimized for humans. So we have to strike a balance and make lots of compromises. And then when we get it right, and it's perfectly set up for us, they upgrade everything. You have to throw it in a bin and then have a new one. And then you say, okay, I have this perfect new one, and they tell you, well, now you need to work on a completely different project, which doesn't need servers, it needs serverless technology, NFTs, blockchain crap. I'm like, well, what about my SQL data? Oh, forget about that, that's last year. We don't need MySQL database. But why did I learn it? Why did you? Okay, so I'm not going to teach you a technology which is going to be obsolete as I am telling you about it. Okay, that's not my point. My point is to teach you programming, how to think like a programmer, because if you think like a programmer, it doesn't matter what the technology is. It doesn't matter if you call yourself front-end, back-end, data scientists, QA, whatever. It makes no difference. So throughout these courses, I will try to cover pretty much all of these aspects, like a little bit of front-end, back-end, mobile, so you get a little bit of taste here. You're not going to become a programmer after this, but I think that your mind will expand. You will understand new concepts and new stuff, and this is what is important, because if I get that right for you, then we can build on top of that. Does it make sense? Everybody's nodding. Punching those cards back in the day, Julia is commenting. I'm happy that the guys are having fun on the stream as well. So that's cool. So what do we do with this development environment? Okay, for the purpose of this course that we are going to run, we are mostly going to focus, as I said, problem-based learning. So we'll have a problem that we are going to introduce and make sure that we do that. Okay? So we all work on a problem, we all get to certain tasks to fix certain things in this problem, okay? So we'll set up our development environment to help us fix this problem. But then I can think, oh, there'll be another problem, different project, different things. So we'll try to set up development environment so that we don't change it a million times, okay? So what I'm going to try to focus on is some sort of web development, okay? Because it's quite complex, it's quite lovely, and we can cover pretty much everything, okay? So web development, we are going to develop some sort of web application, okay? And we are going to make a real web application, and we are going to put it on a real website for the real users, okay? So that's what's going to happen throughout these 12 weeks. That's what we are going to do, okay? So in order to set up the development environment for this web application, we will need the server. Okay? So guys, do you know what is the server? This is the bit where I say to you, okay, I need to change your mind, so you probably have a wrong concept of what the server is. Okay? So I have another thing that I like to do is I have a mic number 2, and I like to put people on spotlight. So I'm going to take this mic, but let me actually switch the camera first. So TDD, that's brilliant. I'm going to take this mic and put it here. So I need a brave volunteer, all right? Now this is a camera as well, so now it's recording you guys, so you are the stars of the show. Julia, what's a server? You are on the spotlight. Sorry about that, darling. You can say I don't know.
I'm afraid I will sound stupid what I say.
It is. Trust me, it is going to sound stupid.
Yeah.
But it's not going to sound any better. So go ahead, say, what's a server?
Well, okay, there are somewhere big machines, and then you can buy space to keep all your data in these machines, and it helps you to run your site.
Okay. So I'm going to take this mic over here. Guys, what's the server? Why is she wrong?
Oh, it was more the data storage that you mentioned?
Well,
Just
yes,
everything.
yes.
It's hard.
It's hard.
Yeah.
But you heard of servers?
It's just a big computer.
Big computer.
Running everything that you need.
Yeah, big computer. It's a big. What's a server?
I don't know.
No, never heard of one. So the guys at the back, take the microphone. Tell me what's the server.
If you ask me, I would say server is like a PC minus all the other stuff.
That's interesting.
Like it doesn't need the same inputs and devices.
Yeah.
It's kind of boiled down.
So here's another programmer. Yeah, give it to him. What's a server?
It's a network of computers.
Oh,
share
that's
the
a network computer. It's connected to a network.
Yeah, but the server is a network of computers, many computers connected to.
Well, but that's
Each
servers.
Yeah. No, I mean,
What is a server? One.
yeah, it's where all the computers are shared in one spot.
No. See, give me back my mic. So guys on the stream, you can type your own answers. I'm not going to read them because I'm sure that they'll be embarrassing, but just for fun, do type. What do you think is the server? Okay, I hope they heard you. If they didn't, that would be even funnier, okay? So, what is the server?
Isn't it just raw data?
Raw data.
Like you just, so on the computer, the IP address is a translated version, right? So that's how you reach your website because you think that's easy for you to enter Facebook. But for the server, it doesn't see Facebook as Facebook. It sees Facebook as a random set of numbers, a certain set of numbers. So
Well,
it's just the purest form of that. It's just where those numbers are stored.
well, probably nobody on the stream heard you because the mic, you didn't have it, but you are all right and you're all wrong, so, and this is the thing, because we have to understand what the concepts are, okay? And, Tanner actually, who doesn't know what the hell programming is, was the closest one. It's minus all the other stuff. So everybody who said it's a very powerful computer, it's actually not. It doesn't need to be powerful. So you are using multiple servers that, like AppSource servers and so on. This is 50 times more, well, not 50,000 times more powerful, this laptop, than those servers. Because my server has one CPU, this has like, I don't know, 20, 30 CPUs, cores, whatever. This one has one, okay? So it's not powerful at all. Well, this one has 16 gig of memory and, you know, my server has 1 gigabyte of memory. I asked you today how much space you have on your hard drive. It's like, oh, 1 terabyte, you know. My server has 25 gigabytes. It's perfectly fine, happy. How many people can it serve? Probably 1 million. With those low specs. So when you say the server is a powerful computer, no, it's not. What it doesn't have monitor, graphics card, doesn't need one. Doesn't have keyboard, doesn't need a mouse. Okay? Doesn't need this graphics operating system, that stuff that we have. Doesn't need that. So it has very basic software, very low spec. It has 1 network card, so it's plugged with 1 cables to the internet, okay? And what you were saying about IP addresses and stuff like that, you know, it is true, but any computer in the world can be a server. So all of your computers that you have in front of you, they can be servers, that's fine. I use my phone, my Android phone, as a server. I installed the whole app source and everything like that, an SQL database on my phone, Android phone. I install everything and I run it as a server. I just put it there, you can connect to it and do whatever you want. It's fine. So it's not different, server is not different than any other computer. It's probably occasionally much lower in specs. But what DJ over there was saying is that, yeah, it's always network of servers, because sometimes, you know, when we have Facebooks of this world, we just can't have one. And it's not smart to have one even if you are running a local bakery site, because of the load balance, so load, and second thing as a backups, you know, so this server fails, what happens, you know, so you have a network of servers helping each other to do the task. Okay, but at the essence is a very dumb computer. Why do we call it as a server? Because I know desktop, laptop, server, okay? Because server, compared to your laptop is general purpose computer, okay? So you can do lots of stuff. You can watch movies, you can play games, you can do work, general purpose. Server doesn't have general purpose. Has very specific purpose, okay? The purpose of the server is what? And I'm going to do another light of spotlights, okay? So guys on the stream, tell me what the purpose of the server is, now that you know what the server is. So I'm going to turn on this microphone, and I'm going to also switch the camera back to the front. Hopefully that works, I don't know. I don't have you in a camera, but there's one person here.
So just going off of what I said the first half, I just see it as a not a reference itself, but more like it's where what you want to get is specifically like a certain page or something like that. And again, it's like reference as a set of number. It's reference as a set of number, but that's like basically what I think.
Okay. DJ, take the microphone. So now that you know what the server is, what's its single purpose?
To serve a simple task,
Which is?
whatever you want it to be.
No, that's general purpose, what we just described, laptops.
But just one task.
What, which is?
Either send or retrieve a data.
Exactly. Okay, so ladies over here, scary microphone comes in front of you. What's the purpose of the server?
Is it to channel?
Channel. Yes, I'm channeling the energy. Yeah, we probably meant some other channeling. Yeah, I'm horrible, I know.
Yes, same thing as DJ said. that
Yeah, well,
to-
I said he is good, right, but don't, you know, I
Yeah,
joked, he isn't.
That's what I meant with channeling. So
What is channeling?
to connect something to something else,
Okay.
and then the server is the root in between. So not the root, but it's the tool in between.
It's the tool, it's the root, it's channeling, okay, so fine. Sam, what do you think?
That it's supposed to be on all the time when you're not. Probably you could do the same with your laptop.
Yeah, I
assume.
can.
But to have a server, it makes it easier that it's always available.
Well, it does that, but that's not its purpose, you know. That we build it so it can be on 24/7 and doesn't melt the plastic and stuff like that, you know. So yes, we build them better, but what's its only task?
Process information.
Yeah, it does process information, yeah, that's correct. Okay, it's not wrong. They are laughing at the back, you know, so.
I don't have the microphone, so I can't say
Yeah, they don't have a microphone. Oh, such a great excuse. Okay, so I'll take the microphone back and I'll sit back. So, sunny scene. Back on the camera. We can hear, Julia. That's great. Okay. When you type www address doesn't connect to the server on your website. Oh my God. Yeah. Something along those lines. Okay, so what is the server? Okay, so see when I say I can give you new information, but I need to hear what you think is in terms to educate you better, okay? So we all as a group roughly know what it is. You are not wrong, you are not wrong, you are not wrong, you know, but we also use confusing language like channeling, you know. Sorry, I'm joking about that, you know, but it's a great example, okay? So to understand each other, first we have to understand the same terminology and what it all means, okay? So it is important what we are doing here, this exercise. As I said, this is different type of course than any other, okay? So, server has one task. It receives a request, process it, and send some data back. Sends response. So, request, process, response. Is that clear? More or less? So you can ask a question. What is a request? Who makes a request? How do you make a request? What is the processing required? And what is the response? You can ask those questions, okay? So to clarify, if you don't understand these things, you just raise your hand, tell me, interrupt me, and say, we don't understand what request means, okay? So we have different types of servers, of course, you know, but by different subcategories of the purpose. But the server, every single one of them, does what I just described. That's what the definition of the server is. So we made a request to it, okay? Internet servers, which host websites, we make a request from our browser typically, but not exclusively to browser. Okay, we make a request. Give me this page. Okay, what the server does, finds all the data that it needs, all the pictures, all the colors and fonts, puts it as a bundle, throws it back at you. Okay, what do you want? You want a different page? Okay, I'll pick up. But I said not always the web request, because the server can also handle requests from other servers through APIs and so on. The mobile application can be connected to the server, so it doesn't have to be a browser, okay? But the main purpose is user sends a request, it processes it, and sends some response back to the user. Is that all perfectly clear to you? Perfectly? Honestly?
One thing about the requests, like, so you send a request, but like, through your browser and stuff, but like, how does it just communicate with the server? Like,
So she's asking, how does it communicate to the server when we send a request? Of course, there is a thing called protocol, okay? That there are, of course, the parts of the network, which connect all that, so you're absolutely right. But in order for our browsers and all the servers to understand each other, they have to follow similar protocol, okay? Because otherwise, if what we said earlier, if they speak different languages, okay? So I think HTTP, I think that P stands for protocol, okay? So people in the world said, okay, let's figure out some sort of protocol, which was kind of invented by Americans in the 70s or something like that, but who cares? So that's what the server is, okay? So, to set up the development platform, we need to set up a server, a development server, a server that is going to be used for our testing, okay? So this server can be just like a real server, but nobody can see it on the internet. It's hidden from the public. So it can be a remote server. But it can also be a local server on our computer. As you said before, there's no difference. They are same computers, they're same technology, same switches. You remember switches? So it can be installed on our computer. And our computer is 10 times more powerful than these servers, so it shouldn't be a problem. So we can install server locally on our computer in order to do things, okay? What things do we want that server to do? To get the request, accept the request, process information, send something back. That's what our server has to do. And it's funny because when we talk about language and so on, we have things like Apache server, MySQL server, Ubuntu server, Unix server. What the hell are all these servers? Now let's make it clear, even if everybody on the internet can start screaming, Apache is not a server. MySQL is not a server, okay? When I say server, it's a computer. It's actual computer without monitor, without a keyboard and so on. That's the server. It can also be a virtual server, so it can be a simulation of the server which we run as a virtual machine, so we can have that. So it doesn't even have to be a real hardware, it can be a simulation of one, but that's the server. Now, what I explained, the server is running code, and it's running on it some sort of applications. And the applications that we install on that server are Apache, MySQL, Nginx, Mongo, you name it. Those are the applications that we install in them. They are server type of applications made for the specific purpose that we are describing, but they are not servers itself. It's an application. Apache is application. So don't get confused, even if you say Apache server, and if I say Apache server, I don't mean there's a computer called Apache and it's somehow different. No, Apache and Nginx and all the others are just an application which is running on that computer. And it can run on your computer fine. Okay? So most internet servers run Apache. Okay? Why? Because it's good. B, it's free. If they don't run Apache, they run Nginx. If they don't run Nginx, they might run something called IIS, which is Microsoft servers and so on, you know. So there's like 0.2% running OS X servers, you know. So it can be different operating systems and different applications that are installed, but mostly what you will find on internet is Apache, okay? So we are going to install Apache on our computers, okay? Amongst other things. So you can do three things. You can install it in Windows, you can install it in Macintosh, you can install it in Ubuntu, you can install it in virtual machine, you can even install Apache on your Android phone. I'm not sure about iOS, but probably you can, okay? You can put it on your tablet, you can install it on your television, you know, it doesn't matter, okay? But what we want to do is to be as close as possible to the real environment, okay? So what I will ask you guys to do is to set up some sort of Linux on your computer. I'll help you with that. And then on that Linux machine, because most of the internet servers are running on Linux, okay, and they have different flavors, but mostly let's call it Ubuntu, so that's the one which is predominant at the moment, okay? And I'm going to ask you to install not the latest version of Ubuntu, okay, but Ubuntu 18. And I'll talk about that in a second. So we have Ubuntu running as a server machine, okay? But we are going to cheat a little bit. We are going to add graphics interface to it, okay? So in order to us to be able to do this first bit, what I said, it has to be easy for us to program that server. So if I have to do everything through the terminal, I can, it's going to be hard. So we are going to have a graphics interface so we can click and move stuff around, all right? So we are going to install Ubuntu 18, Apache, whatever the latest version 2.4 something, okay? But what does Apache do as a software, okay? Well, it does exactly this thing, because Ubuntu itself is the operating system. It doesn't do anything. Even if I put it on a computer, which I call server, it's not going to do the request, process, respond thing. It doesn't do it. Just because I call it server, it doesn't do that. I need to install the application which will do this. So the application which will do this is called Apache. Okay? So Apache, once I install it and start it, I have to start the application. If I don't start it, it's not going to do it. Okay? It's going to listen for the requests. When it receives the requests, Apache is going to figure out how to process it, but Apache is not going to process it itself in most cases, okay? And then Apache is going to send the response. Instead of Apache, we can use Nginx or IIS or anything like that, but as I said, for our development environment that we are going to do here, for our problem that we want to solve, we are going to install Apache, okay, which will do this. What Apache can do is so dumb. Okay, Apache is the dumbest piece of software ever. Okay? You know the URL when you type URL. And I will show you URL on my screen, and then I need to switch to my screen mode. Okay? So if I type URL, okay, let's call that URL google.com, okay? So what Luana was saying earlier, when I type google.com, there is a service which translates this and finds the machine by its IP address, so it knows which machine it is. But it's not one machine, what DJ was saying, it's a group of machines, so they figure it out. But that doesn't matter. For simplicity, let's assume there is one machine. Okay, so when I type google.com, first service translates that and finds that machine. Okay? And if google.com, that machine that is connected to this address, has Apache server, if I type this test, it's going to find a folder called test, folder on that machine called test. And if I type abc test / abc PDF, for example, inside of that folder test is going to find the file called ABC PDF. So the request, this protocol that we are talking about, is so dumb. You specify the folders on that machine, and then at the end you specify what a file you want to get. So my request is, go to the folder test, find the file ABC PDF. Apache does that, finds it, and then sends it back to me. So then I download my PDF. Yes?
So without Apache, the code, the URL will not work?
Yeah, Apache will process this request. Something has to listen and hear what the request is, okay, and then find that file or not, because you might be wrong, maybe that file is gone, so it needs to tell you it's missing, okay? But see what Apache has to do, it has to serve all of you. So what the smart thing is about Apache, it keeps track who asked for what, okay? And because it's so simple program, it does it extremely fast. So I don't need extremely fast computer in order for this to happen. If I go, the second feature of Apache, if I just go google.com/test, it's going to find a folder called test, and this is the protocol, the idea. It's going to find a file called index.html. Somebody decided to call it index.html. So if I don't specify which file I want, it will go to the default file name, which is index.html. And what it's going to do, so if I don't say index.html, it's going to find the file called index.html. If I say index.html, it's exactly the same, makes no difference. I made no change, this is exactly the same. So I don't have to type it. So it's going to find that file, and guess what Apache is going to do with that file?
Open.
Nope. Send back. Correct. Apache is dumb. It just finds it, sends it back, finds it, sends it back, finds it, sends it back. Apache does that. It didn't open PDF to see what's inside. It's not going to open HTML. So it's for the web browser where it sees HTML. Oh, I've got HTML, so I need to draw stuff. I got PDF. I will save it on your computer or whatever not, okay? So that's browser's job. So Apache, dumb as hell application running on my computer, which does only that. Few more things, but you have to understand this. Inside that HTML file, I can say, I also need this file and that file. I need a font, I need some CSS to tell me what colors it is, and I need some pictures. So then your browser figures out, oh, this HTML needs more files. So it's going to go back and make another request to server. Send me font, send me picture, send me CSS. So I can display all that to the user because the HTML told him that it needs additional files. Okay? But as you can see, this is very static. Give me one file. That's it. And then give me another one and give me another one. There's no intelligence here. Okay? And this is all what we call hard-coded. You always get exactly the same file. I can request this PDF file, abc.com, abc.pdf. I will always get the same file every single time. Okay? So in order to make stuff more interesting and personalized and so on, we need two more things, okay? We need a database, okay? So, and we also need some programming language, which will, I'll come to that in a second, make stuff dynamic, okay? So what is a database? And now is the time for another round of questions. So I'm turning on my microphone. You're my test bunny. What's a database?
In database, you can store information.
Okay. I can store information in files too. But you're not wrong, you can store information. But what is the difference between the database and the file?
The structure.
The structure.
Because it is a file.
Sorry,
It is a file, right?
the database.
.db or something?
Yeah, yeah.
It's a file.
The database is stored as a file on a computer. Okay, so it is a file, but the difference is the structure. So what's the structure? That's different.
I don't know.
Okay. Do you know, DJ?
It's just it's a place where you can store anything you want for your application, and then you can also retrieve the information or a specific part of the information.
Yeah, but I can store everything what I want on my desktop too, you know. You see desktops of people storing everything on it, okay? So,
Yes, but you can't allow another person on the website to access your desktop whenever they want.
yeah, I'll put password.
Yeah, you can do that, but the database is more general and you can add as much information as you want on it.
Okay. What's the name of that dog? Benny. So Benny, what's the database? Yeah, I need to get the camera to show the Benny. I don't know, can you see guys Benny? But Benny is great. He's been listening very carefully. Anyway, what's the database for? What's the structure difference?
Well, isn't it that like, although it is a file, it's like made up of like basically different like inputs of like what it's supposed to do with different files. Like you don't just have, for example, like a website is just like, it's everything about that website and its functionality.
Okay, not sure that I got the last bit, but it doesn't matter. So yeah, the problem is I can store everything in a file on a computer. And database, Sam was right, is a file, but the difference is the structure, okay? But why is it different, okay? Let's say I have a file which has information about every citizen of Maastricht. Everything about them in one file, okay? And I want to find something about some person. Now, however I organize that file, even if it's Excel or something like that, it's going to be horrible. It's going to be ages of scrolling, reading, to find that information. So the database is application, again, which has the sole purpose of storing data, yes, but also retrieving this data has to be fast and easy, okay? So it has its own kind of programming language instructions, how I can very quickly get the information that I need, okay? So I don't have to search for it for ages and so. So you will all right. It's storing lots of information typically, but it's a very structured way. But what we are saying is the database is a piece of software which runs on our computer, which also does exactly the same thing. Takes a request, processes it, and gives some response. So when they say it's a server like MySQL server, it kind of is, but when I said server, I mean hardware machine. This is a piece of software which does the job for that machine, okay? So you send a request. I want everybody whose name starts with A. That's my request. Then the database goes and very quickly goes through the whole list, finds everybody whose name starts with A, and gives you result, okay? So that's what the database is for. But then I change one letter in my request, B, and then the database gives me a completely different result. And I change one more thing, I want surname, and then it gives me a completely different result. And I said, I want them sorted alphabetically, and I get that. Okay, so the database is giving me the data that I need when I need it, okay? So that's the point of this application, okay? And I have to install it on my computer and run it, okay? And most of the computers on the internet use MySQL. Why? Because it's typically free and it's very reliable and it's easy to use, relatively speaking. So most of the computers in the world use MySQL. So we are going to use that one too. And we are going to use, I think, version 5.7, not the latest one again, for reasons which I'll come back to at the end. Okay? But then the last thing what I mentioned was making stuff dynamic. Okay? So if I say I'm on a website and I click people in Maastricht, I want to have a little search box. Okay? So when I type whatever I type in a search box, it gives me a list of the results. So Apache can't do that. Database doesn't know that I requested that, so I have something in the middle. Okay? So what we are going to use is a programming language called PHP. Okay, so this PHP we install on our computer. It's like an application, okay? It connects to the Apache. So if you go to the same thing what I described before, okay, and I will switch my scene to here. So if I go to google.com/test, now it's not going to open index.html, index.php. It's going to open this file. Okay? But it's not going to send it back to the user. No. So now fun things start to happen. So it has a PHP processing engine which will read that file that you requested. It will read that file and execute the code on the server. And part of that code can be connect to the database and get me whatever that guy asked for. So you make a request here, Apache gets it, knows PHP is installed because you installed it, so it calls the PHP scripts, programs, codes, whatever it is, which are executed on a server and do whatever we wrote as a programmers in that script, which can be, get me all the people whose name starts with A from the database, package that, and send it back to the server. But we have a problem. Send it back to your laptop, who uses laptop and so on. But we have a problem because browser only knows HTML. But I requested a PHP thing, which is not HTML. So this PHP also needs to do a crazy thing. It needs to generate HTML, which will be sent as a response to the user. So not just it has to connect to the database, get all the data, but it has to generate how the page is going to look like. On the server it generates, and then sends that as a response. And then whatever user typed in request, we get a different response because our intelligent PHP code does it differently. Okay? So, we are going to install PHP version 7.3 on our machines. Okay? It's again not the latest. So do you guys know why I don't want to install the latest Ubuntu, latest PHP, latest MySQL, and so on? It might be bug, for example. What else could be a reason?
You already started programming with one of the versions?
You already started programming, so it can be a legacy thing. So I already have stuff written before, so if I upgrade it, it will break it, okay? So I am forced to do that. So there are multiple reasons why I don't want to go for the latest and the greatest. But the problem is that if I don't have problems, I can use the latest and greatest. That's the best thing, okay? But that's not a real life. In real life, I always have the problems. So these versions that I'm giving to you are used by most servers right now on internet, okay? So most people use that. There's most information about that. They are best tested, most reliable that they are, okay? So why am I not using PHP 5.7? Because by the same logic, 5.7 has been around for a longer time, and then it has more users, more documentation, and more of the stuff. Why I don't use PHP 1 in that case?
They don't support anymore the old versions.
Yeah, but it's my choice. I make a website where I say PHP 1, I install whatever.
You might have more libraries in the 7.3.
Yeah, but if libraries, he said that there's more libraries in 7.3. But the thing is that if 7.3 was for 3 years on the market and 5.7 was for 10 years, which one has more libraries? You know, logically, the older one will have more. The newest one will have the smallest amount, if that logic is true, which isn't. But, you know, the thing is that if I use very old versions, okay, which have been around for a long time, there are security issues. Hackers try to hack those, and they know all the holes. So this is why most of the updates are to patch the holes, security holes, I mean. So if I use something which is very ancient, everybody knows that. This is how you hack it, this is how you crash that site. And they are going to do that. So I shouldn't use obsolete, non-supported technology because of those reasons. Now, probably at the moment, 7.3 PHP also has some well-known exploits and bugs and stuff like that, and I should really upgrade to 7.480 and so on. But it doesn't mean that 8.0 doesn't have bugs. They are just not discovered yet. Okay? So again, it's this compromise of, do I go for the latest and greatest? Don't get all the libraries, my old code will not work, and so on. I might have unexpected bugs that will be discovered 2 months later. I just launched the greatest website, 2 months later somebody finds a hole and, you know. So greatest is not perfect. The latest and greatest is not perfect all the time. So is the oldest. So this is why I say, okay, let's do it somehow in the middle or very high towards the latest. So you have PHP version 7.3, 7.4, then 8, and that's it. So we are not far away. It's not a big difference. And same thing, MySQL 5.7, the next version is 8. How these people count, I don't know. Why is 8 coming after 5.7? Don't ask me. So what I need you guys to do is set up your development environment, okay? And we will have kind of like a working session on Thursday because I am sure you will get stuck multiple times, okay? So I want to see where do you get stuck, okay? But what I need you to do is set up a Linux machine, okay? And I want you to set up Ubuntu. And I want you to set up Ubuntu version 18, which you can download from their website for free, okay? Now, the great thing about Ubuntu is you can actually run it on your USB stick. You don't even have to install it. So you can just have a USB stick and install it on that, okay? If you don't have space, you can have it on that. You can also partition your hard drive. So if you have lots of space on your hard drive, you can make a partition. So let's say I have 1 terabyte and half of it is free. I can shrink this partition. I need, let's say, 100 gig. I don't need more than that. As I said, my server is 25 gig, but I will add some other software, additional software to make my life easier. So let's say I had 100 gig. So this 1 terabyte partition, I shrink. There are instructions and YouTube videos, how you do it for Windows, for Mac, for this, for that, I don't care. So you shrink that. You back up your data first, because if you lose your data because of this training, not my fault, or Alihabas or anybody else. So back up your data. If you're not sure, ask the question. You know the channels. So you can shrink your partition, so you have 100 gigabyte free, and you can install Ubuntu on that 100 gig. And then what's going to happen when you turn on your computer, it will ask you, do you want Windows or Ubuntu? So you switch from one to another, okay? So it's really good because you have your, fun Windows where you watch your Netflix and stuff over here, and then you switch to your work environment, which is set up just for work. If you are using Windows 10, but even 11, you can install something called WSL, okay, which is Windows Linux System crap shit. So you can actually run Linux Ubuntu inside of Windows without switching back and forth, okay? You can do that, but that's not how it's going to be set up on your server in real life. So it is far from, you're not going to run Windows and then inside of Windows some sort of fake machine. It's better to actually download virtual machine like VirtualBox and install Ubuntu in the virtual machine, because that's closer to real system, okay? But the problem, if you install it virtual machine, it's going to be slow. error. Okay, so, and one thing what programmers hate when you click something and it takes 5 seconds for page to load. Oh my God. When it's so annoying. You say, oh, what's 5 seconds? Trust me, you want this to be instant. You can also install Apache and all this stuff just on Windows natively. Yeah, you don't need, you just download the app, install it. It works. Actually, it does. But for some reason, it's the slowest version ever. So if you have Windows and you install MySQL, Apache, and PHP, it works fine. It will work fine. It will be just slow as hell. You can do the same on Macintosh. It will work quite fast, but if you install it on Linux, it will be the fastest. So Mac is almost as fast as Linux because they are based on the same grandparent, Unix. But Windows, for some reason, everything is so slow, so you don't want to do that. Okay? So as I say, the best thing to do is to have a separate partition. In the separate partition, you install Ubuntu. But if you can't do that, you can have it on USB stick or external hard drive. If you can't do that, you can have it in virtual machine. If you can't do that, you can also download LAMP packs. So LAMP packs, and what am I showing on this stream is this. XAMPP and similar, okay? So if I go for this, basically this works for Mac and all the others as well. You can just download this and it will set up your PHP and database and Apache and Perl and who knows what, you know, just download, install, everything is set up for you. You can do that. Okay. Or you can do, there are different versions, so you just say, I don't want 8, I want 7.4. So you can find one with 7.4 and 7.3 and so on. So you can install this, okay? But the thing is, this is not on the server. This is easy for you as a user, but you can't install this on the server. And it's not perfectly representing how the servers work. So I noticed things that don't work in here, and then work on a server, or other way around, which is even worse. They work fine with XAMPP, whatever it's pronounced. And I tried them all. MAMP, XAMPP, there are thousands of these, you know, even for the Mac, there are different ones and so on. Doesn't matter. Okay, so if you try. Okay, it's easiest to install, but it's not going to work very well. So as I said one more time, the best thing to do is install actual Linux on your computer. Okay, that's the best thing to do, if you can. If you are on the Mac, if your computer is a Mac, it's a different story, because Mac almost runs Linux as it is. It's kind of very Linuxy. Mac comes with Apache built in. You actually, if you have a Mac, you already have Apache. You already have some PHP installed, so it's not a problem to install it, and you use this brew package manager to install everything, so you can get it up and running quite quickly. And it works quite well. So if you have a Mac, it's a different story slightly, okay? You don't need virtual machine. You probably don't need to do the partition and install this separately, but it's even not possible anymore. Mac used to have some bootloader thingy where you could have two partitions, Windows and Mac, so you can switch and Windows and Mac and Linux. Those are old Intel Macs, so if you have older Mac laptop, you can still do that. If you have a new one, M1 chip silicon thing, forget about it. It's not going to work. And then there are additional problems because if you have M1 chip, you're almost better running in simulator. It was horrible to set up development environment on this laptop that I'm using here, which is that Silicon. Why? Because everything is running on a completely different type of CPU, which is not Intel, it's ARM-based, so the whole machine code is different. And none of these applications are compiled to run on that because it's new, so it doesn't work. And then you go online to find help, but since it's new, there's nobody wrote help. Everybody's complaining, oh, my stuff doesn't work on this new Mac. Yeah, it doesn't. Give me a solution. No, nobody knows. So, as I said, you have multiple options. It depends on your circumstances what you're going to choose. But at the end of this week, I would like you guys to have some sort of version, working version of Ubuntu installed. On that Ubuntu, I need you to install Apache, the latest version 2.4, whatever it is. Apache is fine. They don't release a new version every 5 seconds. PHP 7.3, MySQL 5.7. And then install the VS Code, Visual Studio Code, okay? Because we need to edit the code, and Visual Studio Code is the best suited application for what we are going to do. Okay? Visual Studio Code is a text editor. Okay? It's called Integrated Development Environment, or IDE, and you have so many. You have PHP Storm, Eclipse, NetBeans, Xcode. You have many of these. So you can write the code in Word, Microsoft Word, if you want to. You just type text, save as PHP, save as HTML. It will work. Okay? So what do I want from my text editor? Because I spend lots of time in it. Okay? What do I want from it is, first of all, that it's fast and lightweight. Okay? So I don't want something huge like Eclipse or NetBeans because it takes them bloody 10 minutes to load. And everything is slow. I want it to be as snappy as possible. Okay? Second thing what I want is I want to be able to customize it to suit my needs, okay? So, and I want it to be free, of course. Okay, so this is free. To customize it, it has millions of extensions, and they are easy to install. So you can customize the color, the font size, whatever you want, okay? It's fast, easy, but I don't care about fancy stuff, okay? It has these 5 icons here, okay? So this is extensions, okay? So if I click this, you get to some sort of app store which you can download extensions for everything, okay? Including very useful extension to MySQL, so you can connect directly to your database and see what's inside. Very useful, okay? So we are going to use that extension when we talk about MySQL in one of these lessons. It has this, which is very easy to debug my code. And we will have a session on debugging your code, 1 week of debugging, because that's the most important thing. Then it has this, which is our repository manager, so I can make changes, push, pull, do all the tracking, you know, if I made a mistake, I can go back in time, I can collaborate with people and so on. And as you can see right now, it tells me here, even in summary, that I am 37 things behind or whatever not. And it has really nice search and multiple searches, so I can find whatever I'm looking for very easily, which is very important because you're like, oh, where was that part of the code? What file did I open and so on? And of course, it has nice organization of, these are all my files and this is the timeline. I can see what happened. I can even have a developer console and terminal, which I do need. So I can do that, so I don't need to go out and open 10 different applications. So out of the box, it comes with quite a lot. And for the purpose of this course, it's fine. But also it's very good if I do PHP, but also JavaScript, C#, Vue, Angular, doesn't matter, mobile development. I can still use all this, same thing. It's quite versatile as well. So if you learn shortcuts and stuff like this in this, you will become quite fast and so on. But if you decide to use a different one because I don't know, use it before, it's also fine. Okay? So I want you to install Visual Studio Code, not the full Visual Studio, which also exists, which is big and cumbersome and, So hopefully we'll have the development machine set up. But we also want to set up some software. Okay, so I want to set up my website. So let me show you something. I go to appsforce.com. Okay, and appsforce.com opens this website. Okay, when I go to appsforce.com/login, it opens some login page. If you guys go on appsforce.com on your computers right now, you won't see this. Because this website doesn't exist. There is no appsforce.com on internet. You can try it, but there isn't one. Why? Because this is my local version. I'm simulating a website which will be called appsforce.com, and you can see how fast it loads. Instant, and I can do all sorts of tests, boom, tum, tum, opens, and so on. So what we are going to do also at the end in order to be able to start our journey is once we got Apache, MySQL, and all that to work, we actually have nothing to display. So we are going to display this. We'll get this some demo version of some software, which is going to be AppSource, and inside of that AppSource, we are going to make some changes, learn things, how to do all the stuff that we plan to do over the next 12 weeks. So I'm hoping that we will have actual working website set up for you on your computers quite quickly. Then we will be able to then edit something and see that change on our website immediately. And then a week later, we'll go in details. How do we do this? How do we do that? How do we, all sorts of stuff. Okay? Now, I want to know, do we have any questions? Okay? What does Ubuntu do in that process? Okay, it's online question. So Ubuntu processes the requests. Well, Ubuntu doesn't process the requests, okay? Ubuntu is operating system running on our server computer, which runs our applications, Apache, MySQL, and PHP. Okay, so Ubuntu is the operating system. It doesn't do anything, it just runs the application. I have to run application on some operating system, so Ubuntu is that. Okay? So, any questions that you have? Yes?
If we're going to partition our hard drive, how many giga do we need?
If you are going to partition the hard drive, 100 gig is more than enough. Okay? you can run the whole thing with 25 gig, okay? But typically what you are going to install is some additional software, okay? So you are going to have the GUI, the operating system, which will take some space, but then you want to have some sort of chat applications. You want to have different browsers, you know, so I tested on Chrome, tested on Firefox, and you want to have Skype and, you know, so you will add some applications which will add to some space, okay? There is an application called Postman, which we, lots of us, when we do the APIs, like to do, you know. So we add applications, so when you give yourself 100 gig, it's fine. Unless you want to develop Unity 3D stuff, then you need much more. But we are not going to do that during the training course, so for this web stuff, 100 gig is more than enough. I think you can get away with 50, but yeah, if you have space, give it 100. Will be working with GitHub to share code or like this? Yes, we will be working with our internal version of GitHub. You know, so we'll have our repository and we will be able to share our codes between us. And we will have a big session on how do these GitHub repositories, okay? So, as I said, you know, it's a really good tool, but it's not easy to understand and things can go wrong. The repository is the version control. So that's why we have a 1 week to just do that, you know, to master it and so on. But we are using our internal version of Git. Any other questions?
Just wondering, what is the difference between PHP and JavaScript? Is it difference?
What is the difference between PHP and JavaScript? Does anyone know here in the room? It's a really good question. You know.
Actually, I also don't understand the difference between long languages, but PHP is only backend. It's only when you communicate with server.
Yes. So the main difference is PHP executes on the server. So you make a request, the processing happens on the server. And then you just get a response. So PHP is a server-side language. JavaScript is executed at the front end. It's executed by the browser. So the server has to send you data, and then the browser runs JavaScript to make sense out of that data. Okay? So the JavaScript is the front end. It executes in the browser in 95% of the cases. Some great guy had an idea, why don't we make a JavaScript a server-side language too? So they did. And then they are trying to tell us, yeah, this is a great thing, you know, and old-fashioned developers like me is like, no, it's a horrible idea. But you can do that. So JavaScript has some packages and stuff like that, Node.js and whatever not, which you can actually run stuff very quickly. You can build your own JavaScript language. You don't even need Apache. You can all run in JavaScript. So, but it's not meant in this current stage, it's not meant and optimized to do that as a server-side language. It's a rather new technology. There are many things that can go wrong. So for this course and everything that we are doing, we will keep JavaScript to its original purpose, just execute on the browser side. So on the front end, on the user's computer, it executes. But we will have a week where we are talking about JavaScript and different frameworks like Vue.js, Angular, and so on. So we will cover that in more details. Any other questions?
Okay, so the difference between all languages is that they just use for different purposes.
Well, there is, you asked the question, I don't know, did the guys hear it on the stream? So you asked the question, what's the differences between these languages as the purpose? And there is quite a lot of overlap, okay? So you can do quite a lot of things in Python, which is exactly the same in PHP, which is exactly the same in C and JavaScript and so on. So there is a lot of overlap. You know, and then you have this group of people like data scientists, you know, they all learn Python and they between themselves know Python, so they're kind of like, Python is the greatest thing. You can do data science in PHP. Will you find as much documentation and lots of people who do that? No. So it becomes like kind of choice, you know, but it's not better, you know, as such. But again, this is an excellent question because it brings me back to my first topic, which was, I'm going to teach you how to think. I'm not going to teach you programming languages. There is no difference between PHP, C, and all the others, except some semantics and few rules and so on. In a nutshell, they are exactly the same, except HTML, which is not a programming language. So that's a PHP, okay, that's JSON file, that's XML file, you know. For us, it makes no difference. I can find you JavaScript files here, and this is a SQL file. So they all have their own programming language, but do you understand what this means? What do you think this will happen, you know, even if you never studied MySQL? What do you think this will do with the database? It will delete the data in the table. Which table? It will delete in a table TI activities, okay? And what does this next thing mean? Create a new one. So you guys speak MySQL. Okay? You're not exactly right. It's not going to delete the data in the table. It's going to delete the whole table with the data. Okay? But you understand MySQL, and there's no difference in PHP. If I do PHP, you know, yeah, that's a wrong example, but let's find this one. What's this doing?
When you get response, send it.
Yeah, well, you read English, you have an idea, you know, so I got some response, and I'll send it back to whoever asked for the response. You know, so what's the difference between PHP and MySQL? Well, syntax is where do you put column, where do you put, you know, there is a little bit of that, but the concepts are the same. And on this course, we are going to talk about concepts. I'm going to give you examples in all of these, okay? And then you can see, oh, I liked PHP backend, I'll do that, you know, I like JavaScript or Angular or framework, or you can choose whatever you want to be afterwards, you know, but at least you know how everything works together and you understand the concept behind it. You can start thinking like a programmer that everything is connected and everything works on a stupid switches. Click, clack, click, clack. Any more questions, or shall we turn off the switch? Have the switch. There you go, computers. No more questions? And the guys on stream were also saying delete the table and so on, if it exists and so on, if the condition is true. Yeah, so I'm glad that they are participating. Guys, the maximum length of these sessions will be 2 hours. I'll try not to overrun them, you know. I think that's the maximum that we can focus, you know, as it is. I need your feedback. You can tell me in person, you can send me a message, you can send me a pigeon with the message on it, you know, I don't care how do you provide it to me. I need your feedback. How good was this? How bad was that? What did you expect? What did you get? You know, anything that you can think, okay, what would you like to see in the next version, and so on, and so on, and so on. Because this is work in progress, okay? So I need your feedback in order to give you better quality content and so on. And feedback can be, Andre, that was waste of time. This was the 2 hours that I spent in my life that I will never get back, and I hate you for that, okay? That can be a feedback. It's not going to hurt my feelings much. Okay, guys, you've been great. Thank you very much. We survived the first one. Bye-bye. Bye-bye, online people.